And live. Evening, everyone. Thanks for coming. Good attendance again, once again. And first of all, thank you very much again to the RFS for providing the facilities. By the way, is it still on track to be sold to the developer by the end of the year? Is that?
Yeah, October, the wrecking ball will be through.
This is our last education night in this facility.
Is that right? Oh, there we go. So, all right. Well, enjoy the night. So last time here with many fond evenings of knowledge taken. Right, Robert, go right into it. We've started right on time, which is great. It's going to be a vehicle theme tonight. We have two presenters. First off is Bob McKay, and he's going to be talking about mechanical failure which led to an electrical fire in the vehicle. And we've got BJ from Fire Forensics who's going to be talking about heavy machinery fires. Okay. And each presenter is going to give a little spiel on what the background is and let them go right into the topic. So thank you, Bob.
Thanks, Steve. All right, good evening. For those who don't know me, my name is Bob McKay. I'm the Managing Director of McKay Forensic Investigations. The company's been around for almost 38 years. My specialty in fire investigation is vehicles, motor vehicles, and so on. So enough of that. Let's begin with tonight's presentation, and you'll understand the meaning of the name of the presentation as we get through. So it starts out that in January 2017 I was asked to examine a 2010 Mercedes Benz 500 LE bus that had caught fire in the depot of the owner's premises. Fairly large company, multiple buses, very well known. In initial discussions with the maintenance director, he made reference to a ping tank and said the ping tank failed. I'm thinking to myself, well, what the hell is a ping tank? So I did a little bit of research on this ping tank to get away from the generic, and it's an accumulator tank which is connected to the air compressor of the vehicle. So this acts as a buffer for the air system, so we're powering brakes, we're powering pneumatics for the doors, this, that and the other in the bus. He also told me that the ping tank got very hot. Well, my question was, how hot did it get? So what we did, in further discussion, we found out that they had a bus of the same vintage, same specs. Basically, it was the same bus. That was our exemplar unit. I must stress, with motor vehicles particularly, if you can get hold of an exemplar, providing us similar specifications, it's going to make your work a lot easier. So we got our exemplar vehicle, and as I've indicated up here, we arranged to have the thing driven around the block for half an hour or so to bring the vehicle up to correct operating temperature. And what I wanted to do was get the air compressor working, and so we could take some measurements on the accumulator tank, or the ping tank. Now, this is the accumulator or ping tank in the exemplar vehicle. It's, of course, most modern buses, the engines are in the rear. Most modern buses have a horizontally opposed engine, and this particular hatch that we're looking through was right in front of the back seat. So got the back seat, we've got a hatch in the floor, and as indicated by the big red arrow, that's our accumulator tank. That little tank, being of aluminium construction, has a capacity of 1.1 litres. So it's not very large at all, but this side connects directly to the air compressor. It's a solid connection, there's no flexible hoses or anything else. The outside, so this is the inside of the accumulator. This is the outlet for it. Goes into a solid copper tube, which half a metre down joins onto flexible hosing and carries the air off into the various components of the bus. The problem is, this is bolted very securely to a bracket. We've got the solid tube bolted here, we've got the other end of the solid tube bolted to the air compressor. Here, we've got a fixation to the accumulator tank. We don't see it down here, but 500 millimetre away, it goes to this flexible tubing, and there's only one bracket that holds it in place. So I started to get a bit suspicious. We got the bus back and we measured the temperature on the accumulator tank with a non-contact 1000 degree thermometer, and as can be seen, as can be seen here, the maximum reading we got out of the thing was 156.6 degrees Celsius. That's important. So it got hot, it got very hot. So we knew what temperature we were going to be dealing with. This is the accumulator tank in the bus that caught fire. Obviously we've got all the damage from the fire, etc., etc. But the important thing is, this is the outlet. As you can see, it's broken away. The other side of it, it's all secure, not going to move, nice and rigid, but that failed. So I thought, well, that's interesting. So moving along, as I said, we've got a 90 degree outlet to a solid tube, and then 500 millimetre away we go to flexible hosing. While it was in the bus, the outlet looked very much like it had come away from the accumulator tank because of metal fatigue. That's only my lay take on it. I'm not a metallurgist, but that's what it appeared to be. So, next thing, what pressure was our accumulator tank working at? Well, there it is, 16 bar, 1,600 kilopascals, or 232.04 psi. So we've got air at 156.6 degrees C at that pressure in that tank, meaning when the back end fell away, we've got a discharge of air. I sort of likened it to be fairly much a blowtorch effect. And as I've indicated here on the slide, we've gone through, we've checked, because if anybody knows anything about the construction of a bus, a chassis and an engine is bought from the manufacturer, in this case Mercedes-Benz, then it goes off to a bodybuilder, and in this case custom coaches who build the bodywork and make it look actually like a bus. So the question was the accumulator tank OEM equipment with the chassis and engine, or was it something that the bodybuilders put onto it? Custom coaches confirmed that it was in fact OEM equipment, so that came with the chassis and the engine. So they had nothing to do with putting it there. From an insurance perspective, that's important, because insurance companies like to launch recovery actions. So who caused that to be there and how it was designed and how it was put in can become a very important factor. So moving along, coming together, automotive electrical harnesses are either polyvinyl chloride, PVC, or polyethylene. PVC melts at between 75 and 105 degrees C. Polyethylene melts at 122 to 135 degrees C. Now, why is that important? Well, we already know we've got air at 156.6 degrees Celsius, pressured at 16 bar. Let's have a look. On this slide, we've got our accumulator tank, red arrow. We've got the broken connection. The yellow arrow here is indicating the main electrical harness to the engine. It's about 200 millimetre away from the end of the pin tank. So when that fell off, the air at 16 bar came charging out of there and hit that electrical harness. Given the melting temperatures, Mercedes-Benz could not tell me whether it was PVC or polyethylene that the conductors were insulated with. Either way, at 156.6 degrees Celsius, it didn't really matter what it was. So, only millimetres away, no heat shielding in place. And by this time I'm thinking, hang on, is this a design flaw? Is this a failure in engineering to think, well, what if that happened? What should we do? Should we protect that wiring harness from heat? Obviously they thought they didn't need to, because they didn't. So, I pulled out the accumulator tank, the piece of pipe that broke away from it, and a metre of the engine harness. Got it back to the office and started looking at it in earnest and photographing everything. So, this is the harness. This bit of the harness was directly in front of the accumulator tank, and as you can see by the three arrows, these nodes of copper, this is where it's gone to arc, simply because all of the insulation on that harness has melted away. The harness is still energised because the bus was actually running when it caught fire. So it's energised. Obviously there's negative and positive conductors in that bundle, and away it's gone. Now, this is the accumulator tank, again back in the office. This is the end where the outlet pipe broke away, and you can see a little bit of the welding here, but the welding around here is completely gone. So it's just completely failed. Now, okay, it may be metal fatigue with this outlet pipe vibrating. It may have been a failed weld on the accumulator tank. I don't know. That's something that a metallurgist would need to look at and determine, given their knowledge and experience. But that's what's caused this fire. Fortunately, the bus was in the depot, and when smoke started issuing from all the vents around the engine, somebody said, gee, it's on fire, and there were, 9 guys with fire extinguishers putting it out. If it had been on the road, it could have been a different situation, a far different situation. And that's all I've got. Any questions, please?
Just curious, the exemplar bus, what's your theory why there wasn't fire in that bus?
Well,
it's subject to the same degree of temperature.
Simply, the outlet tube on that accumulator tank had not failed. Had it failed, we would have had exactly the same situation.
But that it was PVC or whatever that was subject to heat stress?
No, your PVC or your polyethylene is the insulation on the electrical conductors.
Mm-hmm.
Everything was fine while the accumulator tank and its associated plumbing, in the case of the bus that caught fire, being the outlet hose, being intact. But when that outlet hose or tube failed and broke away, it's discharged the air across that engine harness, and the insulation of that engine harness melting has caused the short in the circuit, and that's where the fire has occurred.
Did that lead to retrofitting of, various safety issues?
I'm not sure what the bus company have done about it. Certainly the manufacturers, after I had completed my report, completed a report that hoisted everything back onto the owners of the bus, saying it was a lack of maintenance, which, I mean, given that information, just doesn't hold water. It's quite obvious that, somewhere along the line there's been this mechanical failure, being the outlet tube for or the outlet pipe for the accumulator tank failing and allowing hot air to be discharged across the engine harness of the vehicle. Had there been a heat shield in place between the accumulator tank and the harness, I don't think we would have seen a fire. But the fact that there wasn't raises questions as to whether or not there should have been one in place. So keep in mind, when I'm engaged in these things, I'm normally engaged by the insurance company, and the insurance company are interested in a few select things like, is there an aspect of recovery or subrogation in this situation? Has there been a failure on the maintenance side for the vehicle in question? Obviously, insurance companies are always interested if it's an incendiary fire, but you've got to let common sense rule, and it'd be very unusual for a company that owns 200 or 300 buses to decide to burn one. They're not going to do that.
So are your instructions above and beyond cause and origin, or is it cause and origin and the implications of the cause and origin are up to them too?
Cause and origin implications thereof. Generally my instructions are worded cause and origin, and is there any aspect for subrogation?
Which is a separate issue as a consequence of the cause.
Yep. Any others?
They went and did further testing from the metal guy?
No, we recommended that may be a consideration for them. It never happened. Of course, the accumulator tank, the electrical harness and the outlet tubing was bagged off in evidence. And it's always important to remember, if you're going to take any evidence from any scene, that you treat it properly, bag it off, record it at the scene, and go through a full chain of custody, which we do, and then once we're finished with it, it goes into an evidence facility, which is secure and off-site, and basically it stays there for however many years it requires, just in case there's some sort of action of recovery at a later point in time, and then I can then attest to how that evidence was treated and how the evidence was stored and maintained. Any others?
Yeah, Bob, in your experience with heavy vehicles, have you found that there's a common theme with electrical harness failures at all in relation to buses or trucks or anything like that? The reason I ask is I did the Sydney buses when the one caught fire on the Harbour Bridge, and the specific reason was a failure of a wiring harness in that case, and also other failures. But it was ironic that bus was scheduled to get suppression systems put in it 3
Yeah.
months after the actual accident. But in your experience, do you find that there's a lot of harnesses and electrical?
Yes, you could say that. There's one particular heavy vehicle manufacturer who I won't name. No, it's not actually, but who are renowned for electrical fires. In fact, I looked at one of their 2014 models down in Rotherglen, Victoria in mid-March, and it was an electrical fault in that the negative harnesses that connect the batteries to the vehicle had basically arced right through, and we're talking 15mm diameter cable, so 200 amp capacity.
Sure.
On the 3rd of April, I was in Adelaide looking at a 2013 model of the same vehicle, and exactly the same fault, exactly the same conductors, in exactly the same condition, and I thought that was particularly interesting. And on 8 days later, on the 12th of April, the manufacturer issued a recall notice for 3 of their models that were manufactured between 3 June 2010 and 28 August 2017. That's roughly 4,000 vehicles.
That's quite common there.
And they cited the problem as being the PowerNet distribution box. What they didn't say in the recall is that if you don't get this fixed, your truck is going to burn down. But let's not worry people about this. They also listed VIN numbers of affected vehicles. I ran through all of these vehicles that I covered since January 2016. 3 of the vehicles I had looked at were on that list, and that included the one in Adelaide, the one in Rotherglen, and one I looked at in Wagga in late November 2016. But interestingly enough, a couple of weeks ago I looked at another one of their vehicles. It was in the manufacturing range. It had been manufactured in October 2010, but the VIN number didn't show, and it caught fire because the PowerNet distribution box failed. I thought it was interesting that VIN number wasn't there, but certainly the cause was.
So electrical's common.
Sorry?
Very common then.
For that particular vehicle, yes. I'm almost tempted to immediately say, oh, it's one of those, it's going to be an electrical fault. But
City buses, I mean, they get up to 900,000+ k's on some of these chassis, and when I say that, I mean that's a lot.
900,000, but heavy vehicles, interstate transports can do, 2 million.
Really?
So, 900,000 on a heavy vehicle is nothing. It's half life. But you've got to look at the wiring harness particularly, because you start to get movement in that harness and you're going to get abrasion. So it really goes down to the way that harness is built at manufacture. There's a very well-known brand of trucks. I toured their factory recently when I was down in Victoria and had a look at them and watched. Looking at their electrical harnesses, they use Ziploc ties every 100mm. It is not going to move. Yet the brand of vehicles that I'm referring to that has this PowerNet distribution problem, every 500mm they use a bit of adhesive back cloth bound tape to bind up their harnesses. Now it's been suggested to me, and I've not been able to test it yet, that tape after 3 or 4 years goes brittle and starts breaking up. when it starts breaking up, you're going to get movement in that harness, and therefore you're going to get abrasion. It's the same with road trains. Out in outback Australia, most of the time these trucks are on unpaved roads in all sorts of conditions. So they've got a hell of a lot of vibration, a lot of movement in the harnesses, and depending on the type of truck it is, if you get an electrical fault or perceived electrical fault in one of those, then you need to understand what sort of road condition that it's on and how many kilometres the thing's done. But I'll say this as a word of caution: if the vehicle's moving when it catches fire, you also have to consider all the other things that are going to cause a vehicle to catch fire, and that's fuel and delivery systems, frictional fires through the failure of wheel bearings, braking systems, frictional fires by rotary components in the engine seizing and causing those dry belts to heat up, a whole range of different things. And if you don't consider them, then you're not doing the job properly. Any others? No? All right, thank you very much for your time.
Thank you, Bob. That was really interesting. Actually, exemplary. The idea of getting an exact copy of the vehicle, is that always possible, or is that just...
No, it's not, unfortunately.
Yeah, that's ideal though, isn't it?
It is.
Comparison.
If you look at it, to get an idea of what the thing should look like in its unburnt state, it's really helpful.
Yeah,
seriously helpful.
Yeah, thank you. Now we have some adventures in Mozambique. BJ Jones from Fire Forensics.
We've just had a comment on Facebook about looking at the PowerPoint closely, so we'll try and fix that for the second one. We're doing our best here, okay?
But you don't miss it if you see it live. So.
What's that? Okay, so if you're going to ask a question, can you raise your voices, please? Thank you very much.
Right. I have to apologise, I don't know how long this is going to take, but we do have a...
Speak up so you can hear.
But we have a point where we can stop, and there's a second part to this. So, as introduced, I'm BJ Jones from Fire Forensics Proprietary Limited. Background in pretty much every type of fire there is, but a specialty in heavy machinery fires. So, I'll give you the basics of what happened. I arrived in Mozambique. I was hired by the mine. I have a bit of history with the mine. I've been out there a few times now. And so my client was the mine. Within that, there was a whole heap of other people that came on board as fire investigators for different parties. But I was asked to effectively lead the investigation of the group and control all of the diverse interests. So on the 3rd of August in 2017, there was a fire. There was an EH2311, I'll show you a nice photo in a second, excavator, which is a big Tonka truck digger, like 3 stories high, and it was in operation at the time. There was an operator driving the machine, and there was a nearby truck that was waiting to be loaded. It had been in the workshop for about every 50,000 hours. They actually send these machines off for maintenance. So it had been in the workshop for 2 weeks prior, and then on the day of the fire it took 3 hours to sort of slowly drive out to the site where it was going to work, and then it had a few more problems, so they then did some more work on the machine, and then it was in operation for 2 hours before this fire started. So it's suggestive that it might be something to do with the maintenance. Okay, so at the time that it was at the site and it was then stopped after the 2 weeks, it basically had a bracket on the boom repaired, a right-hand track was not running fast enough, so a control valve was changed, and an oil eliminator was replaced. Now, speak up. This oil eliminator, am I speaking loud enough? Do I need to speak louder?
Just in case our Facebook people don't hear
Okay,
us.
I apologise. Tell me if I'm getting too low.
We can hear you, but they might not be able to.
All right, so it worked for 2 hours before there was a fire. The operator had received the machine around 2 p.m. and completed his pre-work checklist on the machine. And then 4 p.m. whilst prepping a load for a truck, basically he saw white smoke coming across the cab, and he turned around and then he saw a jet of white smoke. And then he called his supervisor without hearing any alarms. This is quite important. And then he saw a fire coming from the right-hand side engine. As he was sitting there, it's the right-hand side engine. He hit E-stop, and if you don't know machines, E-stop basically de-energizes the whole machine, shuts everything down. And then he activated fire suppression system, and this is like your red emergency button that you press. He didn't think that that worked, so he held it down for 3 seconds, and then he heard the system activating. All right? He then got out of his cab, went down 1 level, and he could see between the engines and the supply hoses and the boom that there was a fire on the right-hand side engine. All right? It took then 35 minutes for the fire truck to arrive.
Just one.
And one. We're talking a mine. It takes 40 minutes to get anywhere on this mine. So it took 3 hours to tram this thing out. It's huge. Open cut coal mine, so it's high-grade coal and low-grade coal. And he got treated for smoke inhalation, and he noted that there were no operational issues or concerns during the shift. There was no change in engine, like one engine revving more than the other, any loss of power to the boom, any funniness happening with the boom when he's operating it. And he heard no alarms or saw no indication of lights that would actually have identified the fire in the cab, aside from the white smoke coming across his cab. So this is the team, all right? So there's me. As I said, I'm hired by the mine. I'm running all of these people. We've got John Hutchinson. He's he's Caterpillar representative. He's in-house. He does all Caterpillar fires across pretty much all of Africa. So he knows Caterpillar machines very well. Got Johan Botha, he's from Cummins, so they've got different engines. So they've got Cummins engines in the machines. He brought 2 lawyers, because they were the ones that did the maintenance. And then there's Henk Erasmus, and he's on for the fire suppression system that's installed aftermarket. We've got Alexis Bisson. He's hired by Tata Voltas, which is an Indian company. So at this point we've got me, who's Australian, John, who's English, Johan, who's South African, Henk and Alexis and Davi and Brennis are all South African, but Tata is an Indian company, and we're in Mozambique and they speak Portuguese. So it's awesome fun. So Henk's on for the fire suppression system. Alexis is this schmick-hop, a bit OCD, aeronautical engineer. He knows his stuff inside out and backwards, and he's on for Tata and Voltas, and they do the maintenance on everything else except the engines. But they have to have the handover from Cummins when the maintenance is done and sign off on it without touching the engine. All right, so it's fun. Davi Steiger is for Valo World. They sold the machine to the mine. And then we've got another one, Brenda Scresse, and he's for the broker that sold the machine to the mine. So these are just the fire investigators. That's not anyone else, maintenance, management, anyone else on the mine. So this is our machine, 35 minutes in. So this is the right rear engine, 3 stories high, so you can't see, but there's a ladder and it comes down, and this is first floor, and then there's a second, and then up here is the cab. The wind was coming across the machine, sort of across the back right engine, and then towards the front cab. And this is the machine after the fire. You can see the ladder, the cab, the boom, and this is the engine. This is the engine from behind. We can start seeing some damage, particularly around the fan area of the back of the engine. And this is a bit more indicative of it. And then we start to move around it. You can see even firefighting would be difficult getting a truck in and around there. Usually it's just, one truck. So this is the right-hand side of the engine, and this point here is where there is a door on the inside. So that's the engine compartment. and then this is starting to get into the sort of supply and boom area. These are 2 ventilation machines I want you to take note of, as well as the fan at the back. So this is from the top deck. I'm just going to say selfie sticks are awesome and leave it at that. So this is the cab. This is me practically up the boom. This is the right-hand engine. So the cab driver, like the operator, would have looked back and seen across here, seen the fire coming across. But this is all plate metal, so you wouldn't have seen really fire coming up here. And you can sort of see that there's a lot of heat around here, and it's hard to see with the shadow, but this engine is far hotter than that engine. You should also note that there are actually 8 fire suppression tanks, 2 for each of the engine, because there's a left and a right-hand engine, and then there's 2 for the front supply hoses on each side. All right. So this is our non-damaged left side of the engine, and they're actually mirror. So, well, actually you take one and then you put it on the other side. So something like the eliminator, which was replaced on one side, is in a crawl space, but on the other side is quite open. So the eliminator in this instance is sort of under here. And this is the left-hand side engine. It's quite close, so I've done some sketches. Hopefully they'll be all right. And this is the view from the cab for what the operator had seen. And this is sort of seeing the scale of what he's come down and he's stopped here and he's looked through the compartments to see the fire on the other side. The other truck driver has actually come up with like a hand hose, and they've just gone, that's all too hard, and left, which is good. And they've come down and exited the stairs. So this is our general view of our right-hand engine, and this is the engine, and I'm going to probably show you my little sketch. I do apologise for Facebook people.
We can turn.
Done a very basic sketch because this is the only way I could work stuff out. So this is the right-hand engine from the back with the fan at my back, looking forward, and then the boom is at the front, and there's actually a door here, a little window here that's covered with a skirt, and this is the engine. And the engine sort of goes through with all the supply hoses to feed the boom. But when they call it, it's not the right-hand side, it's actually, this is the front, and that is the rear, so this is the left rear side. Yeah, just to get technical. This is the front of the engine, as it were. So, this is the front of the engine, and this is the right-hand side, and down here is where the eliminator is that was replaced in the 2 hours before it got into operation. And then this is the left-hand side of the engine towards that wall with the hole cut out of it that you can sort of see. And we've got our turbos and our exhaust and so forth. So we had pages of work that was done on this machine. We had to go through all of those items and individually look at them to exclude them or not. We looked at an exemplar machine. We did heat gun tests of this. We did ventilation tests in a 20-minute window while we could look at a similar machine, which I'll go into later. But this is an exemplar machine, just showing the exhaust and how it's supposed to look. And then, again, some more exemplar photos. This now, we come into the area where the eliminator was, and there's uber heat damage, all right? Lots and lots of heat. In particular, you can sort of see all of these metal hoses, supply hoses coming forward, have all just got burning underneath, directional burning, all coming from down below. So this is our eliminator, which is effectively a great big oil filter. And it's lost its casing and it's wedged there. So we had to get that out, which was a boot for it to get down 4 metres. Now we had to actually lower it down quite carefully. And this is the one that was removed in the 2 hours before. So this is the internal filter and a few bits and pieces that we looked at as well that were attached to it. And so we were focusing initially, because of this high heat area, this investigation was over 5 days, so we sort of because it takes so long to get out there and interview and everything. So this lab happened on probably halfway through day 2. Cummins was very happy because we determined that it wasn't really an issue in terms of having a potential fault. It had effectively been bypassed in the actual removal and so forth. So it wasn't actually in operation. And then we looked at the pressure lines. There's no sign of failure. The connection points were all tight, and the solenoid showed that they hadn't fused internally, indicating that there had been no short circuit. So we effectively eliminated out, and Cummins was cheering along at this point. So we then went, and I've just done this little box. I do apologise for my really quality sketch work here. Again, our engine, and this is the front, and this is the rear, and I'm going to call this a skirt, but it's a hole that's cut out, and here's our door. So the little blue things are those grills on the outside wall, and this is the fan. Now the fan pulls the air out the back from the engine. Now we've got a crosswind coming across through that, so it's pushing through those windows towards that front corner and the skirt. And then after we looked at our exemplar and we had Hank running around with a piece of string on a stick to work out the ventilation, we worked out that where the eliminator was, which is this pink area, it's all graded floor, and literally there was a fierce updraft. All right, so try and keep those ventilation points in mind. And this is that sketch with our 2 sort of main areas of interest at the moment, and the eliminator's here, the skirt is here, the door is there, and then there's a turbo. There's actually sort of 8 turbos along, but we're looking at one of them. So at the rear, this is sort of looking, and it's really hard to describe because it's so close in there. Getting a decent photo is quite hard, which is why I've done my quality sketches. This is sort of from the eliminator side, looking towards the skirt, and there's all of this damage at the front, in that front left-hand corner where the crosswind was sort of pushing everything. And these are our turbos, our second stage turbos, 2 of them. There's 2 more up here. In that left rear corner. So that is this corner over here. All right? With the nicely pointing finger. So we went through, after we've eliminated the eliminator, and checked all the connection points on the turbos because they were all switched out in that 2-week maintenance period by Cummins. And we particularly identified this left rear one, which is actually behind. And I'm just trying to give you sort of an overall view. And this is our connection point. There's lots more photos, so don't get upset. And this is the second stage coupling of the turbo. So it's actually in here. And this is the coupling that's actually loose. All of the others are uber tight. And they should be like tooled tight, tighter than a fish's bottom, but they should be very tight. So,
Great description.
excellent. Thank you. So we're now looking at this sort of area in front, and this is sort of actually just in front of the, front of the rear of the engine. And this is looking across. So the turbo second stage that we're looking at is here, and we're looking actually perpendicular to there. And there's a lot of damage in and around here as well. And now we get monkey gym-like, and we go outside. This is the door to the actual engine compartment, and the engine is on the other side of this bulkhead. And we climb up the hoses, and we look down, and we actually see that there's this hole here that was originally covered by a skirt, which I'll show you. And this is the hole covered by the skirt, and there's actually a bit of a V pattern coming up here from this hole, and then there's actually a V pattern going up the other side of the door, which for 4 days out of the 5 we actually had open because we're in and out, and there's like 20 people crawling around this machine. But this is from the actual engine, and we've got a lot of fire damage coming up, and then we've got a V pattern up this door as well. So this is another quality sketch. So we've broken it into grids, and we looked at the eliminator, and the eliminator is just a high fuel load. It's full of oil. The minute it actually burns, it's just going to burn hot, and it's just going to go hard in that really small area that's actually got that serious updraft happening. And then we've got this turbo right at the back and the skirt. So we stripped it, and this is where it got fun with Cummins. They wanted to strip it, so we could only fit like 4 people in that engineering room at one time, so we videotaped it. And they were seen to, because O-rings come in different sizes, put one down, pick it up, play around with the O-ring, and then screw it right on and say, look, it's tight, it's awesome. And then we pulled it off, and this is what they replaced. And this is the technical stuff about that. That the fitting was loose, firstly, that it wasn't a result of the fire. All the other fittings were tight, and the actual fitting name was the adapter for the supply of the second stage turbo in the left rear corner of the right-hand engine. The dodgy stuff. And this is where Cummins comes into it, as I said. They wanted to remove the fitting. It was all done on videotape, so it was not the people that weren't there couldn't get upset about it. They removed, cleaned and replaced the O-ring seal and refitted it, going, this is so tight, it's awesome. And after this ad hoc test, they removed it and it was re-examined, and the O-ring was noted to be crushed, torn and deformed. So this is a normal O-ring, and this is our little O-ring after we've managed to wheeze it onto our fitting. This is the fitting we've removed, and this is actually an exemplar fitting because they just have these engines sitting in a warehouse on site that they can crane in. So we pulled one off a new machine, and this is the fitting and how it's supposed to be. The good stuff. So the fitting was removed and compared to an unused new fitting, and it was determined that the orb union, it's another technical term, was incorrectly fitted on the turbo housing, all right? So it's a weird double screw mechanism. You've got a recess for the O-ring, you've got a nut that screws over it, but to fit the O-ring, you've got to screw the nut down, put the O-ring on, and then screw the nut up, and then you've actually got to get your second fitting nut to come down and do a hard join, nut to nut, with the O-ring sort of underneath the first nut. Does that make sense? I really hope I've explained that all right, because it's quite... Whew. Anyway, so effectively, they didn't screw the nut down far enough to open up the O-ring recess. So when they put the O-ring on, it was on the thread. And then they screwed the second nut down on top of it. So given that damage to the O-ring was what we did after one effort of tightening it and untightening it, you can imagine that the damage would be quite significant. So effectively they put the O-ring onto the thread, and then they screwed it all together, and this created a technical term, soft joint, that contained material that can be compressed like rubber. The soft joint is susceptible to loosening when exposed to heat and or vibration. And at this point, Cummins went, no, that's not what caused the fire. And we're like, well, what else you've got? Because it's an engine and these things just don't catch fire by themselves. And he went, well, we've got nothing else. And I'm like, well, that doesn't fly because pretty much everyone else in the room thinks it's this. And they went, well, what's going to be in your report? And I said, that's going to be in my report. But we disagree. And I'm like, you write your report and disagree.
Was he a fire investigator or was he just...
He was a fire investigator. And then the lawyers stepped in and he was very quiet for the rest of the trip. So, when we looked at the exemplar machine and tested it with a heat gun, and this was not under load, so it was just moving around, it wasn't actually sort of digging up anything. The turbo temperature on the exterior of the engine block ranged from 170 to 500 degrees C, and the actual exhaust was 330 degrees C. So the engine 14W40 oil, which was used in the turbo, has a flash point of 220 degrees C. So I think we can all see there might be a fuel and ignition source coming into contact in that instance. So this is looking at this connection point. So this is the recess I was talking about. So you have to screw the nut right back here to expose this recess for the O-ring. And then you put your O-ring on, and then you screw your nut further down, and then the other join comes up here. So this is our burnt one, and there's no recess for that O-ring. This is another photo showing basically that's where we forced it back a bit. And again, this is the damage. So you can see this door. This is the door that had the fire damage on it. So in terms of this fire, we then had to put it down to what happened in terms of the sequence. So I identified 3 ventilation conditions. So the first one is normal operation before you've hit E-stop. All right, so you've got your engine. It's going happy days, no mechanical problems, no warning lights. The rear fan of the compartment is pulling air out the back. You've got the cross ventilation coming up, and you've got you've got the air coming from the outside, air coming from up and under, and then you've got the fan pulling air out the back. So these means that airflow effectively pulls it out the back overall, but you've got an updraft on one side and a crosswind pushing it all into that right front-hand corner of the engine compartment. So a fire in the left, in this area here, would be pushed back, but then be sucked across the engine, yeah? So then the ventilation condition 2 is that you've hit E-stop because everything's dead, including the fan. All right, and so then you've basically just got this updraft and this cross ventilation effect pushing it forward. And there's a skirt, and it's sort of like a fibrous material, but it just basically gets embedded with oil in this hole that's cut out of the bulkhead, and it's supposed to stop oil and stuff going forward through to hit the supply hoses. But in this case, when that burnt, that was our next ventilation condition. So if you've got a fire with an updraft and a pushing across to hit this skirt's going to burn pretty quickly. And then eventually that's going to breach. So this is our 3rd ventilation condition when that skirt is breached, because that's the point when our little operator's come downstairs and he's seen the fire in the supply hoses coming through that hole. All right? So it does explain pretty much everything that was seen by the operator. In the first condition, the fire's going to be sucked out, smoke's going to come out, it's going to come across because the cross breeze is pushing it across the top of the actual deck, and the operator's going to see the smoke coming across. And then he's going to come down and he's going to see it in the right-hand engine, and that's because at this point it's breached the skirt, it's moved into the ventilation condition 3, and actually progresses the fire forward through the machine. All right, and then, okay. But wait, there's more. So I can keep going at this point. I don't know how long. Do we keep going? Yep. All right. There's more, because there's a fire suppression system that failed totally. So we've got 8 tanks, 4 of them failed, and do you want to know what side of the engine they failed on? All 4 failed over here. All right. So given it's Africa and their attitude is TIA, this is Africa, and it takes you 35 minutes for a fire truck to get out there, you want a little bit more out of your fire suppression than a total failure on 2 tanks and a half deployment on 2 others. Yeah? So let's just say the director of the mine, who's very plain-spoken South African gentleman, was not happy with the fire suppression people. And at this point, Hank was getting a bit sick. So we've got dry tanks, 2 dry tanks, 1 for the rear, so if we set them into 4 groups, so the left-hand engine, the right-hand engine, and then the supply hoses in each. So there's 2 and 2 on each of those sides. So the engine compartment will have 1 dry tank and 1 liquid vehicle system. It's like a fluid liquid. It's not quite a foam, but it's sort of just a powdery liquid. I don't know how to explain it any other way. So on the right-hand side of the engine, we had 1 dry fire tank failed to deploy whilst full of dry powder, and it was full of dry powder at the end. And the examination identified a supply hose between the So okay, I'm going to take a step back and tell you how fire suppression works. It's a different system. It's got its own battery and it has its own activation system. So it's got two activation systems. The first one is that you manually hit it and it activates and it sends like a tank of pressurised gas into the cylinder to fluidise it, and then it charges the line and goes out. All right, so that happens with both of them. The automatic system is that there's a twin line wire that runs around different parts of the engine, and it's got its own power supply, 24 volts, so if you hit E-stop, it's still going to activate. And if it's got a 4.7 kilo ohm resistor, so if this really easy to burn coating of these wires burns because there's a fire, the two twinned wires contact each other and activate the system. But it activates it on a delay, 25 seconds, all right? And then it sends a thing down the line and it charges the tanks with this, like it fluidizes the tank and then sends it off. It's the same pin that goes down, so just think of a pin. It's quite large, it's probably 5 mil in diameter, but so if you hit it, the whole pin goes down, and if it's activated because there's a fire and it's had the 25-second delay, it shoots a little pin that comes out of the centre of the flat surface of this 5 mil diameter big pin. So when you look at the pin at the end of it and you see that this little bullet point has come out of it to activate it, and they say that's the activation from the fire line, not from the manual, you can't tell because the manual could go down and then you have the automatic activation after, all right, because it's got its own power supply. So that could happen after the wires are breached. And that becomes an issue in this instance as well as the tanks. So we've got one dry fire tank over the engine that's failed to deploy. It's over the supply hoses, it's full. And it's been blocked by a small piece of hose debris because there are braided hoses between the little bottle of gas that fluidizes the tank, and it basically has prevented it from deploying because it's been blocked. The second dry fire tank, which was over the engine, had 4 feed hoses coming off, and one of them just burst and just sprayed dry powder all over the top deck. All right, so we had 2 distinct failures for the dry tanks. And then so this is the dry tank, and this is an LVS, and this is a dry tank, and this is an LVS. So these two supplied the forward supply hoses, these two supply the actual engine that had the fire in it. This is a little piece of plastic that we pulled out of one of the dry fire tanks. And this is the failure on the actual hose for the dry fire tanks, dry chemical tanks. So the LVS failure is a little bit different. They both deployed only 50%, and they basically had 3 potential failure mechanisms of which we can't identify what happened. But it could be one of 3, but either way, failed to deploy, and or a partial deployment. However, the thing to note is these are 4 individual failures on individual tanks that were not in, they shouldn't have happened. Like, you could have had 1 failure, but all of a sudden you've got 4. Like, I don't know the statistics on that, but it was just crazy odds for having 4 discrete failures. Because with the LBS, you could have had 1 failure because of a faulty pressure gauge and then 1 failure because of the connection hose block. Now, the only thing that really sort of stood out is that actually had a fire previously, and those 4 tanks had deployed, and the fire suppression people had only just refilled them. All the braided hoses weren't checked for pressure, like they weren't checked, so they just filled them and then off they went. So, sort of leads you to believe that perhaps they should have been a bit more diligent in how they deal with stuff. Now we get down to the nozzles and which were affected by the failures. So we had over this right engine, all right, actually this is the fan at the back, This is the door. These are the supply hoses. These are the two tanks in pink and blue, LBS and dry powder. So the blue, which had the total busted hose, actually came and was the one that was at the top of the bulkhead, which actually looked over the turbo that failed. So we had a total failure of fire suppression randomly over the total area where the fire started. So again, the odds on this is kind of crazy. Then we had a look at where the actual line went for the actual the actual alarming, like the twinned wire. So we had a battery in the engine, in a sort of circuit room here, and then it ran around the left engine, and it just did sort of a general sort of swoop around the outside of the right engine, and then sort of came through that skirt, and then went up to the top of the bulkhead, and then came back here and terminated at the resistor. Now, if you've got ventilation pushing the fire basically across the engine towards an area where there's absolutely no wire or fire twinned wire, you're not going to have an activation. So it wasn't effectively covering the area of origin of the fire, and most likely delayed automatic activation of the fire suppression system. And then there was also this failure at the top deck for all of those tanks on the right-hand side to fully deploy. So in the past, they actually had a fire that had actually been suppressed by the tanks that had correctly activated and operated. So it is possible that this fire could have actually been put out if the fire suppression had worked. So that was pretty much it, aside from the fact that Cummins were really cranky at the end, and the fire suppression people weren't too happy either, because there's at least 200 or 300 machines on that mine site with the contract for the fire suppression in jeopardy because of the actual way that everything failed on the machine. So lots of money involved. These machines are about $20 million each. So, all right. Are there any questions?
I'm curious,
Speak up.
I'm curious that you, obviously from Australia and you go to Africa, why do you think they source people from...
So originally I went out there...
Because you're the best.
Awesome. So originally we got called, we do a lot of work in Australia, and there are a lot of expats that work around the world. And when I was originally called out there, I think in 2015, the director of the mine was an Australian gentleman, and he'd come on board at a point where they had lost, I think, 4 or 5 machines, a couple of excavators and diggers and front loaders, all because people were nicking fuel. And so they had fire. That was another possible, but I thought this is technical, so we'll do the technical one. So effectively they had a fire report for the first fire from the people that had the engines, the people that had the machine, and the fire suppression people, and everyone said something different, and no one actually could explain what happened to this machine. So then they had a fire 6 months later, and then I'm on the plane, and then by the time I've arrived, there's 2 more fires. And then they said, go back and look at the first fire. So I'm there the first time, and I'm looking at 4 machines, one of which is 6 months old, and is so big, they've literally just got trucks to push it into the side of a hill. So it's quite damaged. So the reason we came on board was that we had the rep in Australia, there were Australians over there, and effectively they wanted an answer. So that's sort of where we came in.
Val answers just to say hello.
Hi. Hi, Val.
On Facebook. All the way from Tasmania. Hi, Val. How are
Hey,
you?
Val. So,
How long did that take you to do that?
So that job, I was on site 5.5 days. Berendis, who was on for one of the brokers, he arrived at 2 o'clock on a Thursday afternoon, and his flight landed at 2 o'clock on a Thursday afternoon. It took him another 2 hours to get on site, do the safety briefing, came in, grabbed all the information, and left on the 11 o'clock flight the next day. So yeah, so it took us a long time. This is Africa. It takes so long to get out to the site. These are like huge open cut mines. So you get to the main offices, and that's sort of 20 minutes driving through the bush to get to the main offices, and then you've got to go to the forward sort of supply area, and that's another half an hour, and then you get to the machine, and that's 40 minutes in a bus driving on the line. So it just takes so long to do anything. And because there was a cast of thousands and I was in control, I basically said, we're sharing all the information, and then we come back every day. We have a massive information dump, share photos. I refused to let 12 investigators interview the little operator, because we're doing translations to Portuguese, and that, I don't know, if you say, hi, how are you going in Portuguese, it takes 10 minutes. I don't understand why it doesn't seem to take that long in other languages. But so there's lots of logistical stuff to deal with, and so it just takes time. So yeah, does that answer your question?
Thank you, BJ. That looks like a really challenging kind of
environment
to work in.
I must admit,
even if it's in Australia, it'd be
I'm not an engineer. I don't pretend to be. Fire's my jam, but you just have to know where to ask questions. And thankfully, on mines, there's always a technician. If you just go, I'm looking at an engine and I don't know what that is, and you say, what is that? Someone can tell you. So
have they had any more fires?
No, but they had. I came back and I just finished my round of malaria tablets, 2 weeks, and I was slightly paranoid and sensitive to light, and then they had another fire the first time, so I ended up doing 6 in about 3 weeks.
In Mozambique?
In Mozambique. So.
And you didn't get to see the country?
No.
That's nice.
It's a mine. Open cut mine.
Yes.
Okay.
Right.
So for your troubles tonight, and feel free to donate it back to the education officer. You probably don't drink red, do you?
I do.
Here we go.
Thank you.
And Bob, same. Where is he? Do you drink red, Bob? Red, Bob? You drink red?
I'll drink red.
Oh, okay. All right. He gets one too. Thanks very much so much for your presentations tonight. And again, the exemplar came into play.
Yeah. No, it did, and we only had 20 minutes because they lose the machine over there, and it takes you millions of dollars and a year to actually get it sent back in pieces, like a new machine. So you've lost all that work capacity, because they work 24 hours a day. So they don't like shutting down those machines at all. So we had a 20-minute window. It was pretty crazy.
Yep. That concludes
Awesome.
this evening.
Just like to remind everyone, our next education night is in August, and it's our AGM. It's going to be held at Ryde Eastwood Leagues Club.
Yep.
So AGM is for anyone who's interested in coming onto the committee. You can certainly just get in touch with Bob to nominate yourself if you want to come on the committee. Education night next week. Next time will be something else that Grant might come up with.
Might not be that educational.
Oh no, if you've got ideas for an education night, please let us know ASAP. Otherwise Steve will be talking again.
You calling me ASAP?
Yes, ASAP.
Right, thanks again, and thanks once again to RFS for the use of your the final lectures.
Do you want to say a few words about your conference quickly for the people on Facebook?
There's a question here. Can I ask what Cummins reported, stated, or blamed? Can I ask what Cummins report
Alternative
status?
I don't know. I don't have access to that. That would go to their people, and I do know that because the handover was through Tata Volta, which is an Indian company. Effectively, the mine would sue Tata, and then they would sue Cummins. So it would just be a big, So I don't know what their final report would be, but they were not agreeable to it being.
That was from Dan Fish.
Yeah.
Hope that answered your question, Dan. What did you want to know?
What was your conference like in America?
Can you remember?
Does anyone want to hear me speak? Surely not.
Was it worthwhile?
Yes, I just got back from the International Training Conference, which the IAAI host every year. It was in Frisco, Texas. Very good conference. It's over 650. Sorry, a bit close. 650 people from all over the world. So biggest conference, fire investigation conference in the world. Listen, it was really, really good. A lot of people saying, did you learn anything? I wouldn't say I learned a lot, but certainly it's about networking, and it's certainly about meeting other people in the industry and just getting to see what people are researching at the moment, what people are sort of new technologies was interesting, so that's always good. And it's good just to get over there. I mean, as you all know, the fire investigation industry in Australia is this big, but in the US it's this big. So everything is bigger and better over there, and well, according to them. But yeah, it was very, very interesting. So I certainly enjoyed it. And if you ever get an opportunity to try and get over to the ITC, it's every year. Next year it's in Jacksonville, Florida. So if you can get over there, it's you'll have a cracking good time, and they'll certainly look after you. But yeah, the food was huge, ginormous, and the drinking was minimal. I promise. Excellent. We'll see you next time.